This is part 4 of the lecture 2. We have been looking at the economic evaluation of a process design. We discussed the method for estimation of the capital cost and the operation cost so far. In this section, we want to see some project cost. Then we want to check whether the project is profitable or not, whether the retrofit the project is worthwhile pursuing or not. So whether the strategy for the company is taken further for securing the money for the industrial project. So some criteria is required whether the execution of a certain project is profitable or economically viable. So we needed to look at the evaluation criteria for economic performance of the chemical plant engineering project in this section. So simple economic criteria are useful in preliminary process design. In a full costing would be ideal. But we have the limited information in the beginning. So we may not have all the necessary information for finding out the detailed cost for capital and the operation. But somehow we want to check the profitability of the project in the early stage of the engineering. Then we may not have the detailed information for mass and energy balance. We may not have detailed information for size of a unit. We may not have the detailed information for the utility consumption. But in the beginning, somehow we want to evaluate whether the project or plant engineering exercise is economic or not. Then simple criteria should be used. Otherwise, we are not able to proceed the economic evaluation, the process. So one of the simple criteria is used in the early stage of the process design is the gross margin. So GM, gross margin, is given by revenue minus raw material cost. So raw material cost, as I said, in the evaluation of the operation cost as the dominant factor for the process economics. Okay? So raw material cost is the major one for determining process economics. Then the revenue will be generated by selling your product. So gross margin is typically given by the difference between the profit from the production by selling the product and the raw material to be purchased for production. If you're looking at this simple criteria, we can see that there are other elements, for example, utility cost or invariable cost or engineering cost, for example, contingency. These kind of things have not been included. Why? As I said earlier, we may not have the full information of detailed process information. In the beginning, we may have the rough idea of how much feed should be supplied and how much product can be produced from the site. Then with this limited information, probably the profits through the revenue and the expense through the purchasing raw material or feed cost will be the only costing item we can look at. Okay? So of course, if we have more information, we can add into the gross margin calculation. But in the early stage of design, we do not have detail. So revenue will be taken into account against raw material cost. Okay? Of course, the product and the raw materials, the cost of them will be separate from the variation in the price. It depends on the market. Okay? So you should consider some uncertainty related with price change. Okay. However, relatively speaking, it may not be too sensitive to the price variability. Okay. So there is a certain degree of the uncertainty, but roughly speaking, the selling product is proportional to raw material cost. So there are relatively insensitive. Think about your crude oil product. So if the crude oil, the purchasing cost is increased, the end product of the refinery is going to be increased. So of course, the price is going to be changed, but the relative difference is probably the proportional. Okay, so the gross margin is the one of the thing we can use in the early stage of process design. The second economic criteria is given as return on investment, and the third one is payback period. Okay. So return on investment is given by here on the slide as annual profit divided by total investment. So there are some complex calculation behind calculating return on investment, but in a simple definition is given by profit divided by investment. Okay, so we are investing say $1 million, $10 million. So then that is investment. And what is the profit? So the $1 million per year. Let's say profit is $1 million per year. Then in a simple measure, we can recover all the money in 10 years. Okay. If I have the $2 million profit per year, we can recover the money in 5 years. Okay, that is indication. Okay, that is indication how the project or plant is economic or not. Okay, so here, if the return on the investment is less than the interest that would occur in the bank, it is not worth investing. So you can invest in the beginning $10 million for your plan, then you can have the $1 million per year as a profit. But without investment in the bank, without investment for the process, you might give this money to the bank. If the bank give you the profit, for example, as $2 million per year, I'm not going to invest on the chemical plant because it's better to have the interest from your bank. Okay, so you're not going to get the $2 million from the bank, but this is just a simple explanation. The profit must be better than profit from the bank. Otherwise, people will not invest the money on the chemical plant, okay, for the production of the chemical product. So in that case, return on investment is kind of a measure. Another one, similar to return on investment, is given as payback period. The payback period is given by that expression on the slide. So in the numerator is defined as the fixed capital and the startup cost. Then the denominator term is by the profit after tax and depreciation. So you probably understand the meaning of tax. The depreciation is to be explained a little bit further. That will be explained later from this section, okay? So it's similar to return on investment. So let's say I want to change my reactor. Sorry, this is not the reactor. This is a furnace. Okay, I want to change my reactor. Then because the efficiency dropped down and the conversion dropped down, so energy, okay, consumption is increased. So after say 20 years of the operation, then I'm going to replace with the new one. Okay, so that is the $2 million, sorry, $20 million investment. Then if I'm getting the profit through this replacement, say $10 million per year, the payback years is 2 years. After 2 years, I can recover 20 million. That is the meaning of payback. Okay. If I have the 1 billion profit or the benefit by investing $20 million, then my payback year is 20 years. Okay. So 2 years is better than 20 years. So we can compare the effectiveness of the capital investment for the process. So in that case, we use the payback period. Okay. So it's similar to return on investment, and the payback period is more widely used for the retrofit project. Okay, retrofit project. Another economic criteria is called as the economic potential. So economic potential is given by value of a product and against the cost incurred by the production. Costs include the fixed cost and the variable cost and some expense, for example, tax. Okay. So based on the economic potential, we have the rough idea whether the process is economic or not. When you look at the gross margin, we have the revenue and we have the raw material cost, but we do not have any processing cost. So compared to GM, EP, economic potential, is a little bit bigger, wider, the evaluation criteria for having the cost element on the variable cost and the fixed cost. Okay, so based on the economic potential, we want to find the answer for these questions. So for example, our revenue from product sufficient enough to cover cost. So the major costs are evaluated, then the checking with the profit revenue from by selling the product. So we have the sufficient benefit bigger than the cost, then we will take that project. Okay. Then the problem is when you're looking at this economic potential, we have a slightly problem in terms of putting the number into these equations. So if you're looking at the value of a product against cost, then we may not have the same unit. Okay. So what is the capital cost unit? That is typically dollar. Okay. What is the operation cost? What is the unit for the operation cost? What about the steam cost? What about the electricity cost? That is typically against the dollar, against the time. Okay, so dollar per year, maybe dollar per day. Okay, so the operation cost is based on this time-dependent evaluations. What about the capex? I'm going to buy the reactor at the 5 million. I'm going to buy the furnace at the 10 million. I'm going to buy a heat exchanger with 1 million. There's no time-dependent element directly for the capex evaluation. Of course, the time, throughout the time, the value of the capital, value of the unit will be degenerated, but that will be taken into account later. But for the time being, let's say when you're purchasing the equipment, then we have the lump sum expense. We pay 10 million, we pay 5 million in the beginning, okay, of the project. But OPEX is based on throughout the whole time horizon. We're spending money in this month, we are spending money next month, and for next 5 years, we are spending the operation cost, utility cost, electricity cost, okay? So sometimes we need to have some common basis that is called annual basis. Say we have the cost item A, we have cost item B, okay? But this is based on dollar. This may be based on dollar per year. This may be based on the dollar. Then we do not have the common basis by comparing these two things together. So we need a common basis. What we are doing typically is everything is based on the one common unit based on time-dependent evaluation of all the costs incurred for the project. So typically we are using annual basis for evaluating capital cost and operation cost and variable cost, okay? So this thing is called annualizing fixed cost. So this one should be converted into time-dependent evaluation. That is annualization, okay? This one is given by annual basis. But if the cost is not given in an annual basis, we need some annualization, okay? So for purpose of comparison of design alternative, only certain costs need to be considered. We have the uncertainty in the determining number of the unit in terms of the estimating size, and then there are some uncertain element in the design. Then everything is not clear. So it's wise to take the clear, definite information for the evaluation of the economics, especially for calculating economic potential. Okay, this is the meaning. If you have a different alternative, different option, that's fine. But if the information are not available readily, then you should not consider those uncertain elements into the economic costing. So another criteria is called TAC, total annualized cost. So TAC is given by here, fixed cost and the variable cost. Then again, this is based on the dollar. Okay, this is based on dollar per year. So we need to take the annualization of the fixed cost. So the typically total annualized cost is based on dollar per year. So we need to convert that into dollar per year. How do we do it? We're using annualized capital charge ratio. Sometimes we simply to say annualization factor. Annualization factor. Then the concept of the annualization factor is given as the convert the cost as a lump sum basis to cost on an annual basis. So in a heat exchanger, we're buying heat exchanger in the beginning, say $10 million at the year 2005, okay? Then project lifetime is say from year 2005 to 2025, let's say 20 years. Then what we can do is, for example, multiply annualized factor, then take that, let's say 1/20 as an annualization factor, then the cost will be $0.5 million per year. So here, in the beginning, at the 2005, we bought heat exchanger at the $10 million, but we will consider annually for next 20 years with $0.5 million. So every year we take 0.5 million. For the next 20 years, it will be 10 million equivalent, okay? So we can consider lifetime of the project. But what is the issue related with this simple annualizing factor? Because we did not consider the cost of the money, okay? So 10 million at the 2005 is not going to be same with the 2025, okay? With $1, you cannot buy same thing when you bought at 2005. The cost of money, value of money will be changed, okay? So if you needed to buy the same heat exchanger 2005, it might be 10 million. But if you want to buy the same thing in the 2025, after 20 years, it might be $50 million. It might be $17 million. So cost of money should be taken into account in determining this age utilization factor. So rather than 1/2, maybe 1/15, okay? Maybe 1/10. Then this will be maybe 0.75, maybe $1 million per year. I should take as $1 million per year for 20 years. That is probably the fair comparison in an annual basis, okay? Although summation of this 1 million per year for next 20 years is not going to be the same with 10 million, but based on the lifetime of the project and cost of money change, this might be more appropriate for the annualization, okay? So how do you get this annualization factor? That will be given on the next slide, okay? So annual capital charge ratio, in short, annualization factor, is given with this explanation. So here, if I save a sum of the money A per year, then for the next n years, I saved it and put that money in the bank, and I will have the interest from the bank, okay? So year 1, okay? Then I saved the money. How much? A, okay? Then year 2, I saved the money and put it into the bank. And year 3, I have the money A, then put into the bank, okay? My money is in the bank for the next year. I will have the interest based on this money. Okay? What about the year 2? From year 2 and year 3, I have the A at the year of the year 1, A money at the end of the year 2. So these two will be saved. I have the interest rate. So that is the extra money I can get from bank, okay? So from 3rd year to 4th year, I have the A, another A, okay? That will have the interest rate. Additional interest rate will be accumulated year by year based on the year putting the money into the bank, okay? So if I save the A money for end of each year for n years, then the interest rate will be given as I. Then the value of my investment, that will be given by S. So I have the interest rate then I save the money A, then I have the interest rate, then I have the money, and so on. So that will be sum up as given as S. So that is the S, okay? So in the first year, second year, third year, nth year. So that is the interest rate given to the money, okay? So that is saved at the end of the last the year element. This is the money A put into the first year, at the first year, okay? So that money have the interest rate over the n-1 year. So this is the money I just put into the bank. So I don't have the interest rate, okay? So that is the final element of the A, okay? This amount of the money for over the n years, n-1 years, I have the interest rate for that. So, these expansions in a mathematical term, you will have this expression, okay? So I save the money A, then I have the I have the profit through the interest rate, then the value of my investment overall, S, will be given by that expression. So next, rather than putting the money every year, then I invest big money, P, big money in the beginning, okay? Then I will be waiting n years with the interest rate I, okay? So in the beginning, I have the P, big money, until n years. I'm just keeping that money in the bank, okay? Then I will have the interest rate based on this one. So that is the value of my investment, okay? Value of the investment. So I have a big money, but I have to put that the small amount of money year by year. So based on these two observations, and we can estimate how much we need to pay back the money to bank if I borrow money P. The P was given as a saving, but if you want to do some industrial project, the P money might be taken as the sum of the money you needed to borrow in the beginning. I needed to borrow $100 million in the beginning from the bank. Without investing this money into the chemical plant, the bank will have the interest rate, okay? Then I have this value. So I borrow this money. Bank will charge annually with the amount of the A. Then I need to pay back the money annual basis with the amount of the A for the n years. And I want to recover $100 million in the beginning till the last project year. So if I borrow the money $100 million in the beginning, I needed to pay back to bank with this A amount annually. Then I can cover $100 million. So these two must be the same. So in other words, how much money A must be paid back for each year to pay off a loan of the P. So I borrowed the money from the bank in the beginning. So this one is given by that equation. Two expression is equal to be the same. Then the ratio A against P is called annual capital charge ratio, okay? The fraction of total initial investment that must be paid back annually to completely pay back, okay? The initial borrowing from the money from the bank. So interest rate, let's say 0.1. In other words, that is 10%. Project lifetime is, say, maybe 20 years. Then you can put into the I and the N. Then you can have the A over P. Okay? Then when you have this capital charge ratio, that might be 0.2, maybe 0.5, 0.6, depending on this interest rate, depending on the project lifetime. Okay? Based on that, you have a different number. Then, based on this annual capital charge ratio, you can apply to annualized capital cost to annual basis cost year. So here we take 1 over 20, 1 over 15, 1 over 10. How do we calculate this? How do we determine this one? This is based on this formula. Okay, based on this formula, based on the interest rate you take, based on the number of years you take, then you have the charge ratio, annualization factor. Then apply it for the capital cost, multiply with annualization factor, then you have cost in an annual basis. Okay? This one is the typical cash flow diagram, okay? Typical cash flow diagram. So in the beginning, the cash flow is dropped down, then the eventually goes up, then have the profit. At the end, it's stopped, okay? So we have some element of some change in the behavior of the cash flow pattern. So here we have the cost of the incurred by the early stage of the project. So then in the beginning, we needed to provide the costing for the study of the project. Then another one, cost is suddenly increased quickly. This is because of the procurement and the construction. So this is mainly on the engineering or feasibility study. So in stage B, we have the procurement. Procurement means purchasing of equipment and the construction of the plant. Then we have the big cash required for procurement of the equipment and the construction of the plant. Then the cash flow is dropped down. But then another one is, there are another element of the drop down that is related with typically working capital. Before starting up the project, we need some working capital. So there are some dropping part in after EPC, engineering, procurement, and the construction is done. Then this one, this part is startup. In the beginning of the process, then they either take a time to have the steady state condition. So in the beginning, you might not have the full production capacity. Then the startup require additional the process control and management. So before getting into the full production, it'll take a time. It may be a few months. Then you will not have the big profit. So that's why we have the little bit plot, the plot area. Then after this, from this one to that one, until that moment, that is the full production. So full production means we have the full benefit of the selling the product. So we have some meaningful the revenue from this project. That's why we have the increase in the cash. But then after maybe 30 years, maybe 40 years, then the efficiency of the process is declining. There are a lot of competitors outside. So it's not profitable anymore. So it's dropping down the cash flow. The profit is dropping down, efficiency drop down of the process. So the revenue and the margin or the benefit of the running the process is decreasing. So then the company decide to have the shutting down the plant, okay? So the company decide to shut down the process, then we don't have any benefit by selling the product, but we can recover working capital. In the beginning, we have the working capital here, okay? We have to provide some money as a working capital in the beginning, but then we can recover some of the working capital, okay? We might recover some money by selling the plant, the site, so the land can be recovered as the additional money to be recovered at the end of the shutdown. So these are the elements related with those things at the shutdown stage. So this is a very typical cash flow diagram. So until that moment, we do not have any the positive the cash flow, okay? So we have the negative cash flow until that moment. So after that, we can recover the money and have the profit. So that is defined as the payback time, okay? So that will be gone. Then we have the profit after this moment. So until that moment, that is time required to have the economic operation. So that is the indication of the profitability of the project, okay? So that is given as payback. Some project is the early payback time, but sometimes some project did not have the short payback time, okay? So that will be better. That depends on the project of the chemical industry, okay? So another thing which I needed to discuss from this section is the depreciation, okay? So depreciation is the non-cash expense that reduces the income for tax purpose. So the effect of depreciation charge is to reduce taxable income so that the corporation pay less tax. So depreciation is something like this, okay? So we have the reactor. I bought year 2010 at the 10 million, okay? What about 2011? What about 2012? What about 2020? I'm expecting to operate this plant for next 10 years. Then I bought at the 2010 for the reactor. I'm going to use until 2020 at the price of the $10 million. What about the 2011? I bought 10 million. Can I sell this one to somebody? Nobody will buy it if I want to sell this one at the price of 10 million. What about the 2020? Anybody to buy this one? 10 years old reactor, nobody will buy it, okay? Because this is used equipment. If I want to sell at the 2012, how much you can sell? Maybe 7 million. If I can sell the 2015, how much I can sell at the price of what? Maybe 3 million. In the beginning, it's $10 billion, but after a few years, the value of the equipment is dropped down because this unit is used one. Okay. So depreciation is effectively an allowance for wear, tear, and deterioration of the property as a result of its use. After 5 years, the 10 million to 3 million. But what happened to you? You are losing $7 million. I spent 10 million. I'm just operating. After 7 years, I'm losing 7 million. Okay? So that will be compensated by in a tax arrangement. That is called depreciation. Depreciation is a non-cash expense that reduces income for tax purpose. Okay? So we are cutting down the tax by considering depreciation. What happens is the profit is the $20 million for year 2012. But year 2012, I'm losing the value of the equipment money, say 2 million for this particular year. Then what, let's say tax rate is 10%. What is the tax based on the 20 million? Then the tax will be 2 million. Okay? But let's say this is a depreciation. I'm losing $2 million for year 2012 because I'm using this $10 million equipment. So I bought at the 2010, $10 million. In this year, I think we are losing value of 2 million. Okay? So that is depreciation. Now what is the actual tax? We are not using tax based on the 20 million. We are using tax based on 20 minus D. That is 20 minus 2. So the profit is taken as 18 rather than 20. So then we take the 10% tax rate. So the tax will be 1.8 rather than 2 million. That is the effect of depreciation. Okay? We compensate losing the money throughout the year for the capital investment or some other things in the process. Okay? So that is the meaning of depreciation. So effect of depreciation is to reduce taxable income so that corporation pays less tax. Okay? So different countries have the different depreciation allowance. It's a country specific. The tax authority have the rule, but each country has their own rule for the depreciation. So this is very country specific. Only capital asset like a plant, equipment, the building, software, intellectual property can be depreciated. But you should be careful in terms of the taking depreciation. So the depreciation cannot exceed the initial investment. So I'm buying 10 million. I'm using 2 million as a D, and I'm using 2 and a D. I'm using, the 2 as a 2015, but then annually adding up these three will be 6 million. The remaining depreciation will be this 6. So I cannot use it like that. I have 5 this year, 5 this year, 5 this year. Because after 2 years, $10 million is now used as a depreciation. So I cannot use from third year for the depreciation, okay? So based on the number of years, based on the cost of the equipment, then you need to have some strategy, okay? So there are a few equations to calculate the differentiation. So the P is the profit from your company. Then based on the depreciation, then taxable will be changed by that equation, okay? So the P minus D will be the taxable income I. Then the tax rate TR will be applied after taking this depreciation, okay? So the tax to be paid by the company will be actually reduced. So cash flow is that given as the income minus tax, and then depreciation is added back for the cash flow. So the role of the depreciation is to decrease the tax and then increase the cash flow, okay? So the reactor was the $10 million. So year 1, year 2, and year 10. Now we have the 1, 1, and then 1. This is the typical linear arrangement for the depreciation. So the straight line depreciation allowance may be used, but I have to say it's not going to be always the case for taking linear expression. So some company might have the 0, 2, 2, 1, 1, something like that, okay? So as long as this summation is 10, this summation is 10, it is fine, because each country has a different depreciation rules and depreciation the strategy. So different tax, the allowance for the company tax management. So each company may have a different strategy, okay? Again, the cash flow should be discounted to their present value, because we have to consider, for example, inflation rate. So inflation rate is given by I here. So cash flow at the present time will be devalued through the inflation rate of the I. So that will be given by this equation. So for example, 100 unit of the income next year is not going to be the same value of the money, because today that will be worth of the 90.91 when interest rates taken as 10%, okay? So interest rate 10% should be used and should be taken into account for calculating present value of the cash, okay? So for this year, if you are earning 90.91, then the 10% of the interest rate, that value will be inflated to be as 100 next year, okay? So the time of value is taken into account for evaluation of the cash flow. When you're adding up this discounted cash flow over the n years, that is called NPV, net present value, okay? So year by year, we have in each year, we have the income, we have depreciation, we have the tax rate, then we have the cash flow. Then cash flow can be inflated based on the present value. Then we have the full information of cash flow for the particular year. N years, we have the income for the N year, we have the depreciation for the N year, we have the tax rate for the N year. Then we can calculate the cash flow. Okay, then cash flow can be devalued and turn that into the present one. So when you're summating these costs, adding up and in an accumulated manner, that is called NPV, net present value of the project. So we have the annualized discounted cash flow, then adding up over the N years. So the first year and second year, nth year, and the final year, okay? So we have the summation, that will be net present value of the project. So we are introducing another the factor called discounted cash flow rate of return, so known as DCFR or R. So NPV, the net present value, depends on the interest rate I. If this factor is the interest rate which results in NPV equal to 0 after specified number of the years. So so that is the number of years. That is the NPV, net present value, okay? Some project is something like that. Some project may be something like that. Some project may be something like that, okay? Then the DCFR or R means this is the year of the interest, let's say 20 years, maybe 30 years. It's a given. And at the end of the project, the final NPV becomes to 0, okay? So if we're thinking about the same project, if the interest rate is high or interest rate is low, what is the meaning of the high interest rate? We needed to pay more money back to the bank. What is the interest rate is low? I can have more earning because I'm not paying too much big money to the bank. Okay? High interest rate means less profit. Low interest rate means high profit. Okay? So in the same project, we have different interest rate. Okay? So if the interest rate is the decrease, it will be going up. If the interest rate is increase, then this profile will be dropping down. Then when this final NPV becomes to 0, that interest rate is called DCFROR. So the net present value becomes 0 after specified number of years. That rate of the interest rate is called DCFROR, okay? So we need some iterative procedure. So based on the I, we calculated NPV. If the NPV is bigger than 0, then I'm reducing interest rate, then calculating again. Still bigger than 0, then I'm increasing interest rate until I have the 0 NPV at the end, okay? So when the profile goes up, interest rate is low. If the profile goes down, interest goes up. So based on the iterative procedure, we can determine I. So I have a plant or I have a project. I calculate DCF-ROR. Then the interest of DCF-ROR is, say, 15%. The meaning of DCF-ROR is such that I can cover up, say, for example, 15% of interest rate charged by bank. Some project, so DCF-ROR is interest is 5%. I can cover up to 5% of interest rate from the bank. Which one is better? This one is better. I can cover high interest rate because this project is more profitable. This is not profitable too much, so I can cover up 5% of the interest rate from the bank. So high DCF-ROR will be better. So decision to go ahead with the project will generally depend on the value of the I. If I is low, the project is not profitable too much. I can only cover up to 5%. So I'm not going to borrow the money from the bank. What should I do? I kept the money in the bank. So it would be better to leave the money in the bank rather than invest it. For this one, I can cover up to 15% of interest rate for the bank. The project is very profitable. So rather than putting the money in the bank, I'm using it. I'm generating money because the process is profitable. So this is the kind of the threshold value, whether the process is profitable or not. So high DCF-ROR means it's more profitable. So we can compare different things, and higher DCF-ROR will be more desirable. This is a summary of the chapter 2. We have a different issue for checking the profitability of the process, but then once we have the design, we need to look at the capital cost and the operation cost. Then using the economic criteria, then profitability should be evaluated and checked. Okay. And the economic analysis is quite important. Without having the profitability, we are not able to continue our engineering project. So we review how to calculate the capital investment and the other operation cost evaluation. So I hope you understand the importance of the economic costing in the context of chemical process design.